Now this lesson shows you a couple of new things. We're going to set up a class to receive keystrokes and then create a new font object. The purpose of the program is to display strings of text at various locations in the window. Now here's how that works. This is our standard main line, but it has one added feature. This call right here to add key listener adds the address of an object to an internal list of the frame class. Whenever a keystroke is made, a call is made to the appropriate method of every object in this list. Now the list is normally empty, so keystrokes are normally ignored. So we need to add whoever we want to get the keystrokes. In this case, the object we've added is the same one that's going to be displayed in the window. Let me show you. This is the Canvas class that displays the window. Now, this class also implements the interface key listener, so it can be treated as a key listener object. To implement the key listener interface, it's necessary to provide bodies for three methods: key pressed, key released, and key typed. Now each one is passed a key event object that contains a description of the key. The key press method is called once for each key pressed. The key released method is called once each time a key is released. The key typed method is called once each time a key is both pressed and released. Now for this program, I could have used any one of these three methods, but I just left the bodies of two of them empty and put the code I needed inside key pressed. Every time a key is pressed, the value of the position variable is incremented by 1. If the result is greater than 4, the value is started over again. This number is used to position a string in the window. Notice there is a call to repaint, which schedules a call to the paint method to redisplay the window. The very first thing we do in the paint method is create a new font object. This one uses the Times Roman font. In a little bit I'll show you how to get a list of all the font names available to you. The second argument to the constructor specifies the style of the font. In this case it's bold. For a regular font, just specify plain. In this example, we have specified it as both bold and italic, which is done by ORing the values together. Integer values can be ORed together with the vertical bar. The last parameter is the point size of the characters to be displayed. Now, this is a bit odd. Every measurement in Java is specified as a number of pixels, except this one. The size of the glyphs in a font is specified as a number of points. A point is 1/72 of an inch. Now this causes some problems because there's no real consistent relationship between pixels and inches, so you just have to diddle with the font size and pick something that you like. In a later lesson I'll show you how to get around this and create text to fit in exactly a specific size. With this call to set font, the default font is replaced by the newly created font and stored inside the graphic object. From this point on, any text drawn by this graphics object will use this new font. The graphics object now contains the information necessary about the font and about the window, so it can produce a font metrics object that contains all the measurements of the new font. This program is going to be placing the text around the edges of the window, so it needs to know the size of the window, and that's retrieved in the form of a rectangle object that contains the height and width. The switch and case statements uses the value of the position variable to determine where to draw the string in the window, this time through the paint method. If the value is 0, the string is drawn at the top center. The position of the beginning of the string is calculated by subtracting the length of the string from the width of the window and then dividing the result by 2. We want the text against the top of the window, so we position the baseline of the text as the height of the ascent down from the top. To position the text to the left, The beginning of the string is set to 0, and the vertical position of the string is set halfway down the window, subtracting half its height. This is the position of the top of the characters, so it's necessary to add the value of the ascent to find the location of the baseline. At the bottom, the text is centered, the same as it was at the top, but the vertical position is set to the height of the rectangle minus the value of the descent. To position the text against the right side, the starting point is set to the width of the window minus the length of the string. And finally, using the same sort of calculations we've used before, the string is centered in the window. Once the string itself has been set and the position of the string calculated, this line of code paints the string into the window. Here's the result. Each time a key is struck, the text appears in a new position in the window. Now, even though the calculations are exact, the placement of a string is not an exact science. You'll position strings that show up a little bit off of whatever you intended, but that's because there are too many people involved. Somebody designed the font, and that person may have made some letters a little bit off. This happens in the best of fonts. They make them look pretty instead of making them exactly fit the dimensions. And there are some programmers that wrote the code for the canvas object. It may not fit exactly pixel by pixel inside the frame. This can vary a bit from one operating system to the next, one version of Java to the next, and it seems like from one day to the next. The moral of the story is this: do your calculations to figure out exactly where you want things to be, but be prepared to go back in and fudge the numbers a little. If you're creating a design, you'll always have to finagle something, and that something is usually the font characters.